evening, everybody. Today, I welcome you all for the session of discrete time Fourier transforms, DTFT. That is, this is lecture number 6 actually. Now, this topic comes under video syllabus under module 4 for 4th semester students, ECE 4th semester students, especially. Or else this can be to any other students, any other electrical students, TC students, IT students, any other students, anybody, right, who is interested in projects doing in signal processing, BE, MTech, PhD, or some of you are right very interested in core domain, right, signal processing as core domains in companies. If you are looking for them, all these signal systems topics, lecturing hours is very, very important, very basics, right? And those who are interested in signal processing areas, go for this, right? All of you go for this, all these properties and all these lectures, right? Last sessions, till now, we have in DTFT, we have discussed, right, about the DTFT of signals, and then properties, other properties, for example, linearity property, and time shift property, time scaling property, all the property we have seen actually, right? Now here, today we will discuss frequency differentiations property and convolutions property, right? Very two most important beautiful properties of today is frequency differentiations property and convolutions property. Now, let me see one by one. Frequency differentiations property, right? Let me see this statement. First, see this word here itself, using this frequency differentiation property itself, you can write the statement. For example, differentiations is done in frequency domain. That's what frequency differentiation. Now see, x of e power j omega, derivative of x of e power j omega versus d omega. That's the name. Frequency differentiations property. Let me see now statement. If DTFT of discrete time Fourier transform of x of n is given by x of e power j omega, that is frequency domain, then discrete time Fourier transform of x of n multiplied by minus j(n), let's say x of n signal multiplied by minus j(n), to that is equal to DTFT of this is equal to differentiations of x of e power j omega, that's what frequency domain, x of e power j omega, take derivative, differentiations of this versus d omega. That's what frequency differentiations property. This equivalent of this x of n multiplied with minus j(n) is equivalent of this is in frequency domain after taking DTFT, it is equal to derivative of x of e power j omega versus d omega by d omega. That's the statement. Now let us see now how to prove. Proof is very, very simple, right, and very simple and straightforward. See this RHS and see this LHS. Then see that, then accordingly you prove. For example, you know that first line, right? Standard expressions for x of n, input x of n, time domain signal is in frequency domain. It is written as x of e power j omega is equal to summation n is equal to minus infinity to plus infinity x of n, your input, into e power minus j omega n. This is standard equations to write sequence from time domain to frequency domain. Now what is required actually? Derivative of this. Now take, therefore, differentiate, now right? Differentiate both sides with respect to omega, is asking. See this RHS. Then just differentiate both sides with respect to omega, right? Looking RHS. Then what will happen? Derivative of x of e power j omega by d omega is equal to derivative of this. Derivative of, right, summation n is equal to minus infinity plus infinity x of n e power minus j omega n. See this with respect to d omega. Then what will happen? Then left hand side you leave, because see this, what you want to prove? You want to prove, right, this derivative of x of e power j omega d omega is equal to DTFT of this. So this side already I got. Now just do the right hand side. Left side don't worry, right? Now change this order of summations and differentiation, or they take derivative of this. What will happen? Change, yeah. Next, take the derivative of right hand side, take derivative of this, right? What will happen? Derivative of summations n is equal to minus infinity plus infinity x of n, take this outside, right? When you take derivative, Summation n is equal to minus infinity plus infinity x of n, take it outside. Then omega term is here, e power minus j omega n. Now derivative of e power minus j omega n by d omega is equal to this only. Right? What will happen? Derivative of e power minus j omega n d omega is nothing but minus j n into e power minus j omega n. It is like this. E power minus 2 x, like derivative with respect to dx is minus 2 into e power minus 2 x, like. Now that I will get. You see, summation n is equal to minus infinity plus infinity x of n minus j n. See this, retain this as it is, right? The derivative of this is minus j n into e power minus j omega n. Now group this minus j n into x of n as one group. Why? Because is, now see what you want to prove. This is what actually you want, right? Prove that this is equal to this. That's why I am grouping that as one term, minus j n x of n, your LHS, into e power minus j omega n. Rest you will retain. Now this is, compare these equations with standard equations of x of n, x of e power j omega. What will happen? Standard equations of frequency domain representations of x of n is written as x of e power j omega, frequency domain, is equal to summation n is equal to minus infinity plus infinity x of n, any time domain sequence, into e power minus j omega n. This is same as this, right? In place of x of n, I am having minus j n x of n, right? The frequency domain representations of this is this. Frequency domain representations of this is this. Derivative of x of e power j omega by d omega. The rest of the things are same. N is equal to minus infinity plus infinity, n is equal to minus infinity plus infinity, e power minus j omega n, e power minus j omega n. Therefore, we can write dtft of this is equal to this. That's what I am writing. dtft of minus j n x of n can be written as derivative of x of e power j omega by d omega, which is nothing but RHS. Hence, the frequency domain representations of differentiations of frequency domain representations is proved. Right? Let me quickly repeat. What is that? Frequency domain representations, frequency domain differentiations properties, nothing but this statement. dtft of x of n is x of e power j omega. dtft of x of n multiplied by minus j n is given by derivative of, now see this, derivative of differentiations of x of e power j omega frequency domain versus d omega. This is the statement. Then how to prove this? Simple. Write first standard equations, x of e power j omega versus x of n. Differentiate, see the RHS, differentiate both sides with respect to omega. Then you will get the differentiations of x of e power j omega by d omega is equal to differentiations of this. Then this is same. Summation n is equal to minus infinity plus infinity x of n, take it outside. Derivative of this e power minus j omega n, you write, that is nothing but minus j n into e power minus j omega n. Then group full this as one term, minus j n x of n, after which is what required, e power minus j omega n. Compare this with standard equations of x of e power j omega versus x of n. Then in place of x of n, I am having minus j n x of n. Therefore, dtft of minus j n x of n is nothing but derivative of frequency domain. Right? Hence the property proved. That's all frequency domain property. This is very, very useful in case of writing a signal processing. Right? Now, second property is convolutions property. This is very, very important property. Right? This is done for two signals like Z transform. Right? Z transformations are LTI systems we have done here. Right? Take two sequence. Let me write the statements. If dtft of x of n is x of e power j omega, frequency domain. dtft of y of n sequence is y of e power j omega, right? Frequency domain. Then prove that the convolutions in time domain, that is x of n, convolutions of y of n, is equal to dtft of these convolutions is equal to z of e power j omega, which is equal to multiplications in frequency domain, that is x of e power j omega into y of e power j omega. This is not into, this is linear convolutions. Convolutions of x of n with y of n is nothing but multiplications of two signals, x of e power j omega into y of e power j omega. Then what is the significance of this statement actually? This is very, very important statement, convolutions in signal processing. What is that? For example, if you take in a signal processing, complex signal processing, More than 2 signals only you get always. For example, if 2 signals are there, then if you want convolution sum of, right, 2 signals x of n into y of n, if you solve, nearly half to 1 page, right, 1 page you need to get y of n, to get this output. Z of n is equal to 1 page you need. Now, to do that in frequency domain, if you, that is equivalent to, the convolutions in time domain of 2 sequences is equivalent to just one word. This is equivalent to one word, that word is multiplications of 2 sequences in frequency domain, that is x of e power j omega into y of e power j omega. That means 1 page processor work is being reduced by one word. That much time you are saving, that means speed increases. That's how today's processors is fast. And in today's processors applications, each processing applications wherein you are doing 1000 times convolutions only, that means 1000 pages is reduced to 1000 words only. That's how, right, you are increasing the speed. This is very, very important property. Here also you are using. Next time digital signal processing subject full you are using this one. Now, proof is simple. Proof for this is very, very simple. Now, what is that? First, write for x of n sequence, write the frequency domain representations. X of e power j omega is equal to summation n is equal to minus infinity plus infinity x of n e power minus j omega n. Similarly, write for y of second sequence y of n. Right, frequency domain representations for y of n is y of e power j omega is equal to summation n is equal to minus infinity plus infinity y of n e power minus j omega n. This is for x of n sequence, y of n sequence. Similarly, I want LHS, Z sequence. Z of n, same way, frequency domain representation is Z of e power j omega is equal to summation n is equal to minus infinity plus infinity Z of n, your input sequence, e power minus j omega n. Now, whatever is there in Z of n, that is LHS is there, now substitute here. What is Z of n? That is LHS. Summations, what is that? X of n convolutions with y of n, 2 sequences, these 2 sequences. Right, just write it here. Summation n is equal to minus infinity plus infinity x of n into convolutions of y of n into e power minus j omega n. Now, what is x of n into y of n actually? This is nothing but there is LTI systems in module 2. We have dealt all this, right? The convolutions sum of 2 sequences x of n into y of n is given by these equations in shifted impulse equation. Summation n is equal to minus infinity plus infinity x of n into y of n minus l, standard equations, right? Just substitute that. In the form of shifted impulses. Instead of k is equal to minus infinity to plus infinity, I am having l parameter, that's all. L is equal to minus infinity plus infinity x of n, y of n minus l into e power minus j omega l. How this is done? This is done in LTI systems. See my previous sessions of LTI systems, you will get these derivations, right? Just substitutions I am doing. Now, change the order of, next step is important. Change the order of summations. We get this summations you write first, this summations you write here. Z of e power j omega is equal to summation n is equal to minus infinity plus infinity x of l, take it outside. Then this summations you write this side. Summation n is equal to minus infinity plus infinity y of n minus l into e power minus j omega l. Now, just order of summations you are changing. Now, substitute this n minus n as m. N minus l as m. That means when you do that, then change the summations. Then the summations changes from the second summation. So from summations n is equal to minus infinity to plus infinity to summations m is equal to minus infinity to plus infinity. Right? I am changing the summations n is equal to minus infinity plus infinity to m is equal to minus infinity plus infinity when I do the substitutions. Very, very important. Right? How I am getting this? It is written here. For example, when n is minus infinity, see this, when n is minus infinity, then what happens here? Then m is equal to n minus n, m is equal to minus infinity minus n, m is equal to minus infinity. You will get summations as m is equal to minus infinity. Similarly, when n is equal to plus infinity, see this, when n is equal to plus infinity, then what happens? M is equal to n minus n, m is equal to plus infinity minus n, m is equal to plus infinity. That means your upper limit is plus infinity, lower limit is minus infinity. That is how you are getting this to this. Now, apply that. Z of e power j omega is equal to summation n is equal to minus infinity x of n. This first summation is same. This second changes to this. Now, summations summations m is equal to minus infinity plus infinity y of what is m? Now see this, for example, n minus l is nothing but m, therefore y of m. Now see y of m, e power minus j omega, e power y of m, e power minus j omega, n is there. What is n? See, the n is there, n is nothing but m plus l. Now see, I am writing m plus l. Now split this, next point is split this exponential, e power minus j omega m into e power minus j omega l. Now bring this e power minus j omega m l into this x of l term, e power minus j omega m to m term. That's what I do next. Now see, therefore z of e power j omega is equal to summations l is equal to minus infinity plus infinity x of l e power minus j omega l. This I am taking inside. Then similarly summations m is equal to minus infinity plus infinity y of l e power minus j omega l. M. This is l, this is m. Therefore this is nothing but standard equations for x of e power j omega frequency domain. This is for y of l, standard frequency domain expression is y of e power j omega. Therefore the output RHS is equal to z of e power j omega is equal to multiplications of two frequency domains sequences, that is x of e power j omega into y of e power j omega. That means convolutions in time domain is equivalent to, see this, convolutions in time domain, see this, equivalent to multiplications in frequency domain. That's what we proved. Multiplications in frequency domain. That means one page work is reduced to, since we know this, just multiply is equal to one word. That's how you are increasing the speed of the process. That's what convolutions time domain is nothing but is equivalent to multiplications in frequency domain. It increases the speed of process, which is what required today. Right? Let me quickly repeat the steps. Very easy only. For example, what is that? This is the expressions. First statement, x of n, y of n is x of e power j omega, y of e power j omega. Then LHS is equal to, that is convolutions in time domain, is equal to dt of t is equal to frequency domain multiplications. Right? How to write that? First write x of e power j omega in terms of x of n. Next y of e power j omega in terms of y of n. Then write z of n in terms of z of e power j omega. Then substitute z of n, that is x of n in convolutions of y of n. We know the standard equations for convolution sum of x of n and into y of n, which I am writing in terms of L. L is equal to minus infinity plus infinity x of n, y of n minus l, just substitutions. Then change the order of summations. You will get this L order first, n order next. Then substitute n minus l as m. Then summation changes from this to m is equal to minus infinity plus infinity. That's what, and how I am getting, see the minus m is equal to minus infinity to plus infinity. It is shown here. Therefore z of e power j omega is equal to summations l is equal to minus infinity plus infinity x of l. First you write. Then second is m is equal to minus infinity plus infinity y of m into e power minus j omega. What is n? N is m plus l. Then split this, bring this inside l and put m inside here. You will get two summations. Summations l minus infinity plus infinity x of l e power minus j omega l, e power minus j omega l. That is equivalent to x of e power j omega. This is equivalent to y of e power j omega. That is how the RHS is proved as multiplications of just two sequences equivalent to multiplications of two equations in frequency domain. It seems, I hope I am very clear, right? This property is very useful, right, in all your signal processing applications. Thank you very much. Let me tell this quote before finishing, right? Very important. What this says? Actually, any successful things happens twice in reality. Any successful things you take, which happens twice actually in reality. Once in their own mind, you ask sports players, the exact will happen in their dreams. Then only it will happen in the field. Second time, it happens in real world. That's what reality which we are all seeing. That's what all successful people says, right? All successful people, if you ask, they will exactly reproduce because it happens in their mind once. That's why especially students use your own mind to study first. Then exactly same thing happens in exams or interviews. Thank you for saying this. Thank you.